All right, today we're getting right down to the basics. We're talking about the very stuff that makes up, well, everything around us, matter. So let's just dive right in.
I mean, just look around you for a second. The chair you're sitting on, the water in your glass, even the air you're breathing, it's all matter. In this explainer, we're going to break down exactly what that means. And we're going to tackle all those key questions that always seem to pop up, especially if you've got exams coming up.
So, first things first. Let's start with the most fundamental question of all. What exactly is this stuff that's all around us?
You know, the official definition is actually super simple. If it has mass, which just means it's made of stuff, and it occupies space, meaning it has volume, then it's matter. A book? Yep. The air inside a balloon? You bet. It's really that straightforward.
Okay, so that's the next logical question, isn't it? If a book and the air are both matter, what are they actually made of? What are the building blocks?
And the answer? It's actually way simpler than you might think. Everything, from the hardest rock to the air we breathe, is made up of these incredibly tiny particles. You can't see them with your eyes, but they're there, and the way they behave pretty much explains, well, everything.
Okay, now these 3 points, they are the absolute key to understanding everything else we're going to talk about. Take that first one. They have space between them. Think about it. That's why when you stir sugar into water, the water level doesn't really go up. The little sugar particles just sneak into the empty spaces between the water particles. And the second point, that they're always moving, that's why you can smell a flower from across the garden. Those scent particles are literally traveling through the air to your nose. Seriously, these 3 ideas are super important for your exams, so make a mental note.
So all that stuff about particles, how they move and attract each other, it leads us straight into the 3 main states of matter we see every single day: solid, liquid, and gas. Let's see how that all connects.
This table right here is pure gold, and trust me, it's a classic exam question. You can often get a good 3, maybe even 5 marks for this. And look, see how it all goes back to those particles? In a solid, they're packed super tight, with a really strong attraction, which gives it a fixed shape. In a liquid, they're a bit looser, so they can slide around and take the shape of their container. And in a gas, man, they're just flying all over the place, so far apart they have no fixed shape or volume. It really does all come down to how the particles are behaving.
All right, so we've got solids, liquids, and gases. But here's the thing. They're not stuck like that. Matter can change from one state to another, and one of the biggest drivers of that change is temperature.
Let's just use water. It's the perfect example. You take solid ice and you add heat. The particles start wiggling and vibrating like crazy until, bam, they break free and become liquid water. That happens right at 0 degrees Celsius. That's its melting point. Keep heating it up to 100 degrees, the boiling point, and those particles get so much energy they escape completely and turn into a gas or vapor. And of course it works in reverse too. Cool the vapor down and you get condensation. Cool the water down and you get freezing.
But wait, there's this really cool exception called sublimation. Some things, like camphor or even dry ice, they skip the liquid phase altogether. You heat them up and they go straight from a solid to a gas. Just a neat little curveball to keep in your back pocket.
And hey, speaking of exams, here's a super practical pro tip for you. If you ever have to do calculations with temperature, you'll probably need to convert from Celsius to Kelvin. It's so easy, you just add 273. Seriously, don't forget it. That's some easy marks right there.
Okay, let's tackle a topic that can seem a little tricky at first, but is actually super interesting once it clicks. We're talking about a kind of hidden energy.
Seriously, picture this. You've got a beaker full of melting ice. You stick a thermometer in it and it reads 0 degrees Celsius. You keep heating it, but as long as there is even a tiny bit of ice left, that thermometer stays locked at 0 degrees. So, where's all that heat going? The temperature isn't changing, so what's happening?
Well, the answer is something called latent heat. The word latent just means hidden. And here's the crucial idea. That heat energy isn't being used to make the particles move faster, which is what would raise the temperature. Instead, all that energy is being used for one job and one job only, to break the bonds that are holding the particles together in that solid structure. It's the energy being used for the change of state itself. And you've basically got 2 types you need to know. There's the latent heat of fusion, which is the energy needed for melting a solid. And there's the latent heat of vaporization, which is the energy needed for boiling a liquid. This is a big one for exams, folks, so make sure this concept clicks. All right, let's bring this all home with one last concept that connects all this particle theory to something you feel every single day, especially in the summer. So first off, what even is evaporation?
Well, the key thing to remember is unlike boiling, which only happens at a specific temperature, evaporation can happen at pretty much any temperature. It's when the particles right at the surface of a liquid get just enough energy to break away and become a gas.
And that brings us to a feeling we all know, right? It's a hot day, you're sweating, a little breeze comes by, and suddenly you feel cooler as the sweat dries. Why? What's going on there? So here's what's actually happening on your skin. For those little particles of sweat to evaporate and escape as a gas, they need a boost of energy. And where do they get it? They take it from their immediate surroundings, which is your skin. They're literally stealing heat from your skin to make their escape, and that's what makes you feel cooler. Pretty neat, huh? And you see this principle in action everywhere. It's why we wear cotton clothes in the summer. They're great at helping sweat evaporate. And it's the same reason those big desert coolers work best when it's super hot and dry, because the dry air allows the water to evaporate really, really fast, pulling a ton of heat out of the air.
So, there you have it. We've looked at what matter is, its different states, and how it's constantly changing from one to another. It's this amazing dynamic cycle. But all this changing, it kind of leads to a much, much bigger question, and this is what I want to leave you with. While matter can change its form, can it ever be created out of nothing or truly destroyed forever? Something to think about.